Hey guys, welcome to your Unit 5 Lesson 4 notes on scatter plots. By the end of the day, you will be able to both graph and interpret points on a scatter plot. So let's start out by looking at a scatter plot. This is a scatter plot. You'll notice that it's comparing the age of a child and the amount of sleep he needs in a day. So like when you are 2 years old, you need about 14 or 15 hours of sleep. See how they correspond like that, right? However, by the time you are 12 years old, you only need under 9 hours of sleep-ish? Cool. And notice that stays the same throughout your teenage years. So you guys should be getting about 9 hours of sleep. And then once you venture into adulthood, it drops into 8 hours of sleep. Okay. So you have your age, and that influences how much sleep you need. So as a child gets older, he needs less and less sleep every day, and then it about evens off. You'll notice that these points do not all lie on the straight line. So while you can draw a line that shows the general trend, or even like this, they don't really fit on that line. But it's like that, right? Cool. So when you're 30 years old, you can assume that you'll kind of need about 8 hours of sleep. Yeah, so plan on that for when you're 30. Okay, so by the end of the day, you'll be able to do those kinds of you will be able to make those kinds of observations. So what we have here are a bunch of data, and when data are displayed in a scatter plot, you can determine whether there's a pattern to the data, or you can determine if there's a trend. So there's not a strict pattern, but here you can notice there's a trend. It's going down and then it evens out. You can also describe the relationship here. As you get older, the less sleep you need. So there you go, a pattern, a trend, or a relationship, right? And there are two ways to describe relationships. You can either describe them by their direction. That is, are they positive or are they negative? You can also describe them by their strength. Are they strong or weak? Is there a high correlation or is there a low correlation? So it's high when it's really strong. It's low if it's really spread out. Okay? So let's show you some examples of what that will look like. So if you have a graph that looks like this and like this, in fact, you'll want to put these two axes in each of your little boxes here. I'm going to show you what positive high correlation looks like, positive low, negative high, and negative low. So let's start out with the direction. When we have a positive correlation, that means the data are trending up. That means that they are, as one increases, the other one increases. So if it's positive, it's getting higher. Now, when you have a high correlation, that means, or like a strong, that means it's really strong. That means that the points are all like close together. They're all very near to the line. However, if you have a low correlation or a weak correlation, then they're not very close to the line. You might have some that are right on the line, but you might have some that are like way out here or way down there. But you can still tell they're still trending up. It's just not as strong as this one. And then the opposite is true. You can have a negative. You can have a negative correlation, one in which it goes down. So as one increases, the other decreases. And so to have a strong negative correlation is to have all these points lie directly on the line, or at least very close to it. However, if you have a negative correlation, just kidding, I'm going to make it a little bit of a different color. If you have a negative correlation that's weak, then some dots might lie on the line, but some are really far out. But as you can tell, they're still trending downwards. So there you go. Sometimes there might be no correlation at all. And when you have no correlation, that's what happens when the dots are just kind of every which way. They're just going wherever. They're just kind of, they're there. There's no relationship. There's no pattern. You just kind of have dots. You just have data. Okay. So let's look at this relationship. Oof, what happened there? Oh well. We're going to classify them as having high, negative, low, or no correlation. Positive, high, negative, low, whatever. So here, let's look at the direction. The direction that they're trending is they're trending down, and they're all pretty close to each other. So I would say that this is negative, and it's a high correlation. It's a strong correlation. It's negative and it's high. Here, well, it's not, the numbers aren't really going up, and they're not really going down either. Here it looks like there is no correlation. Whoops. Because they're not close to each other. They're not anything. This is no correlation. Cool. Now let's kind of just think about this logistically without even looking at the picture. What would you expect? How do these relate? If you were to look at the number of weeks an album has been out and its total streams, well, as the number of weeks increases, then its total streams increases. So I would call that a positive correlation. You know what? I'm just going to write positive like that. Okay. Let's look at this next one. The number of years a person went to school and their income. This won't be probably as strong, but the number of years a person went to school means the more degrees they have. So if they're a doctor, they have a lot of degrees, their income's really high. So I would say that's a positive correlation. The longer you go to school, the more well-paying job you'll have. Okay, what about a person's weight and the age of their car? This person's weight and the age of their car? I mean, those have nothing to do with each other, right? That's got no correlation. Let's just say that no correlation. Okay, what about the number of photos you took on your phone and the amount of memory available? Well, the more photos you take, the less memory there is. So that's negative. We're going to make that red. That is a negative correlation. As this goes up, this goes down. The opposite is true too. As you delete photos, you'll clear up memory. So as photos goes down, memory goes up. So that's a negative correlation because they're like opposites. And then finally, your height and your shoe size. As your height increases, your shoe size also increases. So that is a positive correlation. This one goes up, the other goes up. Okay. Now let's look at this situation right here, and then we'll call it a day. So it says this scatter plot could show the relationship between which two variables? Well, first let's look at the variables that we're talking about. We know that on one side we are looking at y, and on another side we are looking at that needs to be way fatter. We are looking at x. Okay, so if we have the speed of an airplane versus the distance traveled in an hour, well, here I look at that and I think that has a positive correlation, right? The faster you're going, the more distance you'll travel. So that's a positive correlation. And this guy shows a negative correlation. Look, he's going down. We don't want that. Okay. Next, we have the outside air temperature versus air conditioning costs. So our question that we should be asking ourselves is, well, as the temperature goes up, air conditioning will cost a lot because you use a lot of air conditioning. So that's another positive correlation. Let's do this. As speed goes up, distance goes up. Okay, what about the age of an adult and the height of an adult? Well, as your age increases, your height increases when you're a child. But after you get like to 20, you don't really grow a lot. That's just that kind of stays the same. So that's no correlation. No, thank you. Okay, well, what about your distance driven? As your distance increases, the gas remaining in the tank, that goes down. The gas remaining in the tank goes down. So that is the one we want. That has a negative correlation. So we can label this here. This would make sense if we said distance driven and gas remaining. The farther we drive, the less gas we have available to us. There you go. Cool. Cool. That's it. That's how to read a scatter plot. Scatter plots show you relationship and know the difference between a high correlation, so one that's really tight, that's very strong, or a low correlation, one that's very weak, it's very spread out. Positive means they both increase. Negative is as one increases, the other decreases. Yeah. Have a great time on your homework.